This is the ancient symbol from the Egyptian culture called the Eye of Horus. Next to it, this is what's called a sagittal section of the brain. Now, if you took the two halves of the brain and you divided them right down the middle and you pulled them apart, you would be looking at a side view of the brain. And there's a very striking resemblance between the limbic brain, the seat of the autonomic nervous system, and the Eye of Horus. And it's important for you to understand that this represents some type of inner vision. Pineal gland has been known to be called the third eye because once it's stimulated and activated to the next level, it gives us profound inner vision. This is called Fibonacci's constant, or the golden mean. If you were to follow that golden mean right around the circumference of the brain, it would wind up at the exact spot of where the pineal gland exists in the brain. And many different things in nature, from the universe to seashells to the inner shape of a flower, all represent this golden mean pattern. Now, the pineal gland has a simple vein, artery, and nerve moving in, and a vein, artery, and nerve moving out, and it has a very rich and dense blood supply. Take a look at this article that I discovered, Characterization and Potential Role of Electromechanical Transduction, New Crystals in the Pineal Gland. Now, the abstract says, the pineal gland is a neuroendocrine transducer secreting melatonin, responsible for the physiological circadian rhythm control. A new form of biomineralization has been studied in the human pineal gland. It consists of small crystals that are less than 20 microns in length. These crystals could be responsible for an electromechanical biological transduction mechanism in the pineal gland due to their structure and their piezoelectric properties. Now, that's a mouthful of words. But there's only two words that I want you to pay attention to: piezoelectric properties and transducer. Just remember those. Now, in the next page, it says the pineal gland microcrystals appear as a stack of thin rhombohedrons with their flat surfaces normal to the long axis of the crystal. If you were to visualize that, you have these calcium carbonate or calcite crystals that are rhombohedron in shape, that are stacked on top of each other in the pineal gland. And when you apply a mechanical stress and you begin to compress those crystals, the compression of those crystals